Example 2. Consider the gas-phase reaction. We have 1 moles of hydrogen gas reacted with 1 moles of iodine gas in equilibrium with 2 moles of hydrogen iodide gas. Suppose that a flask containing hydrogen and iodine has been heated to 435 degrees Celsius and the initial concentration, okay, so we have the initial concentration of hydrogen and iodine 0.0175 mole per liter each. At equilibrium, okay, so at equilibrium, the concentration of hydrogen iodide is 0.0276 mole per liter. Use this experimental information to calculate the equilibrium constant. So again, let's construct our reaction table first. Since the information given in the question is all about the concentration, okay, so we are going to use the terms concentration here. So we have the initial concentration, right? Initial concentration, the change in concentration, and also the concentration at equilibrium. Okay, so the initial concentration of hydrogen and iodine were each 0.0175, okay, 0.0175. Okay, so since it didn't mention about the concentration initial for the hydrogen iodide, we put it as 0. Okay, so since here the product is 0, so as the reaction proceed, okay, it will produce the product. Okay, so the change in concentration of the product here, since here we have 2 moles of hydrogen iodide, so it will increases into X. Okay, we put X here because we don't know how much it increase. Okay, so the reactants will decrease in, okay, so we put the negative indicates that it will decrease. Okay, so since here is 1 mole, so it will decrease in X. Also here is in 1 mole, so it will decrease in X. Okay, so at equilibrium, the concentration of each gases are 0.0175 minus X. Also here 0.0175 minus X, but for the hydrogen iodide is 2x because 0 plus 2x is equals to 2x. Since at equilibrium, given the concentration of hydrogen iodide is 0.0276 mole per liter, so from here, at equilibrium, the concentration of hydrogen iodide is 2x, so we can find the value of x, where the 2x is equals to 0.07, because the 2x is equals to 0.0276 mole per liter. So x is equals to 0.0138 mole per liter. So we already have the value of x. 2x is equals to 0.0276 molar. So x is equals to 0.0138 molar. So we already know the value of x. So now we can calculate the concentration of each species at equilibrium. Okay, so 0.0175 minus x, okay, 0.0175 minus 0.0138 is equals to 3.7 times 10 to the power of minus 3 molar. So this is the concentration of the hydrogen and iodine at equilibrium. So write down the Kc expression and then substitute the value of each concentration at equilibrium and press your calculator. You will get your answer 55.64.